All right, so to understand the relationships between moles to particles and vice versa, you need to know Avogadro's number. And so moles in general are just a unit of measure in chemistry, right? It's used to measure quantity. And so what he defines it as is 1 mole is equivalent to 6.02 times 10 to the power 23rd molecules. So let's say we had a problem here, right? Let's just dive right into a problem and see how we can use his number here to help us solve. We have, let's not do 10 grams. Let's just say we had 0.75 moles, right? We want to convert this directly into the number of particles. So how would we go about doing that? Well, we know there's a direct relationship. 1 mole is equivalent to 6.02 times 10 to the 23rd particles, right? So we can set up an equivalent fraction just like we've done before. And so we had 0.75 moles, which is our given supposedly. We put that over 1 in the equivalent fraction. And let's set this equal to the number of particles. So we're going to have moles on the bottom because we want to get rid of moles and end up with particles. So the moles will cancel out. And we know that 1 mole, like we said before, is going to be this value up here. 6.02 times 10 to the 23rd particles. And if we multiply across, that's going to give us a grand total of 4.515 times 10 to the 23rd particles. Right? We're just finding using that relationship to find the number of particles. So let's go down here. Let's do another example, particles to moles. Let's say we had 12.01 times 10 to the 23rd particles or molecules. And this is over 1. And so we have our equivalent fraction here, right? And so we want molecules at the bottom and the moles on the top. And we know 1 mole, should have written moles, but 1 mole is equivalent to 6.02 times 10 to the 23rd. That's a really important number. Make sure you remember that for your tests and stuff. So if you just put this into your calculator, you're going to get 2 moles. And that is our answer.